Greetings, Algebra 2 students. This is Dr. Heron talking to you about probably one of the most important sections in all of Algebra 2, talking about factoring. And factoring is a challenge for some students strictly because you are trying to pull apart. You are trying to kind of work backwards within polynomials, okay? So you need to have your factoring skills sharp, and you need to understand kind of what you're doing. So when we talk about factoring, you're doing the opposite of foiling. You're doing the opposite of multiplication within polynomials, okay? So you are going to look at basically you're trying to factor, most of the time you're trying to factor into like x plus some number and then x plus some other number. That's going to be kind of how factoring looks when you're done most of the time. Now, there's exceptions to this rule, of course. So when you're factoring, this is your first rule of factoring, okay? First rule of factoring. GCF stands for greatest common factor. All right, greatest common factor. Okay, so you're basically looking to pull out what's in common. Okay, that's what you're trying to do. You're trying to pull out what's in common. Okay, so then you are going to look for how many terms. Okay, you're going to look for how many terms. So is there 3 terms? Is there 3 things? Okay, does it look something to the effect of x squared plus 4x, plus 5, something like that, okay? Or does it have some number in front of it, like if I put a 2 there, okay? Something like that. If I'm going to do this, then I'll show you how to factor that. That's not a problem. Grouping is when I get to 4 terms, okay? Grouping is when I get to 4 terms. Grouping means like if I've got 4x squared plus 2x minus 3x minus 4. Grouping would be like taking those two and factoring those separately. Okay, so grouping is most of the time going to be used with that. If I've got something in front of x squared, and I'll kind of show you how to do that. Now, there's also a couple of special cases. Okay. And the easiest one is a difference of 2 squares. And that's if I've got like x squared minus 25, okay? Because 25 is a perfect square. So I'm going to have like x plus 5 and x minus 5 would be that factored. And I'll go into a little more detail. There's a couple examples that kind of explain how that goes. Okay. GCF factoring, very simple. What is the biggest number in common? Now, if I wanted to break this down to like old school, way back in the day factoring, you would drop 12 and 36 down to just prime numbers. So 12 would break down into 2 times 2 times 3 times x. 36 would multiply down to 3 times 3 times 2 times 2. Okay, that's multiplying, that's breaking it down to nothing but prime numbers. So then you would pull out what's in common with both. So I've got a 2 here and a 2 here, got a 2 here and a 2 here, I've got a 3 here and a 3 here. So I would pull out 2 times 2 times 3, and then write what I have left. I've got an x here, and then a 3 here. So then 2 times 2 times 3 would just be 12. That's factored. That's pulled apart. Here, 8 squared, 2 times 2 times 2 times x times x. 16, 2 times 2 times 2 times 2 times x. So then I pull out what's in common. I've got a 2, I've got a second 2, I've got a third 2, I've got an x, and I've got an x. So I'm going to pull out 2, 2, 2, and an x, and then write what I have left. I have left 1x I have left 1, 2. I bring this sign with me. So 2 times 4 times 2 times 2 times 2 is going to be 8. And I'm left with just x plus 2. Okay, and if you're starting to kind of pick up on, you know, what's in common between 8 and 16, well, 8, that's good. That's the expectation. I'm just breaking it down to kind of the simplest terms so you see what I'm trying to do. So again, GCF factoring, 39 and 13. 39 is nothing more than 3 times 13 times x, and then 13 times x. So I've got the 13 in common, and I've got the x in common. So that's what I'm going to pull out front. So I have 13x. So what I have left is 3x from the first part. Then there's nothing left on the second part, so I just put a 1. And I have to put a 1 because if I distribute this back through, I need to come back to this. Okay, I can't put like a 0, because if I multiply this through, I'm going to have this 13x, so I need to put a 1 there. So there's my factored answer. Over here, 5x to the 7th, 20x to the 3rd, 40x squared. So the numbers, the things that are coming with the number is going to be x, or 5, and the number of x's is going to be 2. So I'm going to be left with x to the 5th minus 4x plus 8. That would be factored answer. Okay, so now general trinomials. Trinomials, you are working backwards. And what I mean when I say that, you're trying to find what multiplies to 8 but adds up to 6. All right, what multiplies to 8 adds up to 6, there's only a couple choices. You have 2 and 4. So I'm going to rewrite this as x squared plus, actually, I can get away with this because there's nothing in front of x squared. So my answer is going to be x plus 4, x plus 2. Right side, well, multiplies to 12. So you got 1 and 12. You've got 3 and 4. You've got 6 and 2. Well, multiplies to 12, but adds up to 13. 12 and 1. So I can multiply those together, and that's my answer. Now, these work a little different. Notice I've got a subtraction. So I see what multiplies to 4, but subtracts to a positive 3. So once again, I'm looking at my factors of 4, but how can I subtract to get a positive 3? Well, 4 minus 1 would work. So when I do that, that's going to be x plus 4 and x minus 1. Okay, anytime that this second sign is subtraction, then my answer better have one of each. Okay, and 1 addition and 1 subtraction. If that's subtraction, they're going to have one of each. If it's addition, they're both going to be the same, and that they're both going to be that sign. Now, number 8 is a trinomial. It's kind of like saying x squared plus 0x minus 4. So it's asking what multiplies to 4 but subtracts to 0. So you're going to want 4 and 1, 2 and 2. Well, 2 minus 2 is 0. So that's going to be x plus 2 and x minus 2. And if I'm ever not sure, I can always FOIL it back and figure out if I'm right or not. Likewise here, another difference of 2 squares, okay? And the general idea is like if I've got a difference of 2 squares, the first one is something squared, the second one is something squared, then my answer is just going to be a plus b times a minus b. So 64 is kind of like 8 squared. So it ends up becoming x plus 8 and x minus 8. Likewise for 25, x plus 5, x minus 5. And that was the one I kind of showed you at the beginning too. Okay. So, next, this is where things get interesting, okay? Because now I've got a number in front of x squared. Okay, now pay attention because there's a couple steps to this. First thing I'm going to do is take first times last. So I'm going to take 2 times 5 and get 10. So now I need factors of 10 that add up to 11. Okay, well, that's easy. That's 2 and 1, or 1 and 10. Okay, so now pay attention. I'm going to rewrite my middle term with my factors. Okay, so instead of 11, I split that up to 10 and 1. Okay, why would I do that? Because now I'm going to factor by grouping. So what's in common with the first one? 2x, x plus 5. What's in common with the second grouping? Nothing, so I just put a plus 1. Leave it as is. So now my answer becomes 2x plus 1, x plus 5. Okay, so I'm going to rewrite it. I know I'm going to split it from 3 terms to 4 terms, but I do that just so I can break it down to this later. So now here, 3 times 7 is going to be negative 21. So what multiplies to 21 but subtracts to get me 4, negative 4? Well, 3 and negative 7. So now I'm going to rewrite that. 3x squared minus 3x, or plus 3x minus 7x minus 7. I'm going to rewrite it using my terms. So parentheses, 3x, x plus 1, negative 7, x plus 1. Note the sign. Okay, negative 7. Negative 7, if I was going to distribute this back through, negative 7 times positive 1 is negative 7. So now these match up, just like they did over here. So I can put those together. There's my answer. All right. Couple more. Mixing it up. What multiplies to negative 36, but what multiplies to 36 but subtracts to 5, or positive 5? So 36 and 1, 2 and 18, 3 and 12. Let's see, 6 and 6. You've also got 9 and 4. 9 and 4 work. So that's going to be x plus 9, x minus 4. How do I know that? Because I need a 9, because I need this one to be negative. So, and then this goes with the bigger number. So it's going to be a plus 9. 14. Notice, I can factor, there's something in common with all of this. So I'm going to write 2x squared plus 8x plus 15. Okay, so what multiplies to 15 but adds up to 8? So I can write x plus 5, x plus 3. On this one, okay, 3 can be factored out. What multiplies to 5 but adds up to 4? Nothing. That's as far as I can go. That's as factored as I can go. This one, you've got the x, y. It's kind of the same thing. What multiplies to 18 but adds up to 9? So you're going to want 3 and 6. So this is like saying x plus 6y and x plus 3y. Okay, this having the y squared just means I'm going to put y in the second term. There's not much to that. So if the area of a rectangle is 8x squared plus 10x minus 3, find the dimensions of the rectangle. So basically find the length of width, but they are in terms of x. So I need a factor. So I need to take 8 times 3, and I get 24. Well, multiplies to 24, but subtracts to 10. Well, if I start listing these off. Subtracts to 10 is going to be 12 and 2. So I'm going to write 8x squared minus 12x plus 2x minus 3. So parenthesis, 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 parenthesis. So pull out a 4x. I'm left with 2x minus 3. Pull out a 1, 2x minus 3. So when I put those together, there's the dimensions of my rectangle. Okay, factoring is going to be something we do a lot of. We're just going to have a lot of practice because this is one of those things you just get good at. All right? If you have any questions, please come talk to me.